Hey guys, this is the second part of our Algebra Order of Operations lesson. I believe in the last video we left off talking about Nathan and his 5 bags of marbles. So let's review really quick. We talked about how to write that as an algebraic expression, and we talked about how Nathan had M marbles in each bag, and he then added 3 marbles to each bag. How many marbles does he now have? We could write it like 5 times m plus 3, where m plus 3 are the number of marbles in the bag. There are 5 bags. But we don't really want to write it like that. That's a little bit cumbersome. So we just put the 5 right next to the parentheses, and we say 5 times m plus 3. That means that we are multiplying m times 5, and we are multiplying 3 times 5. So another way we could even write this would be to write 5m plus 15 marbles. So we distributed the 5 across both terms in the parentheses. We did 5 times m, and we did 5 times 3. And that's our algebraic expression. Okay, now we're going to talk about Jacob. Jacob also has some marbles. He puts x marbles in each bag. There are 5 bags and 3 marbles altogether. We want to express the total number of marbles in terms of x. Well, let's talk about what's going on here right now. We've got some unknown number of marbles in each one of these bags, and then we have some leftover marbles on each side here, right? So these are different units. We can't just, write 5 plus 3. That wouldn't work, would it? We've got to write an expression for this portion of the equation, which is 5 times x, right? Because there's x marbles in each bag. And then we've just got to add 3 marbles to that whole amount. So if we're going to write an algebraic expression for that, it's going to look like that. We're going to say 5x plus 3. All right. Now, let's go ahead and substitute in a value for x and solve how many marbles Jacob has if x equals 10. So our algebraic expression, again, was 5x plus 3 marbles. And if Jacob has 10 marbles, that means we're going to multiply 5 times 10 and add 3. Okay, so according to the order of operations, we want to multiply 5 times 10 first, and then we're going to add our last 3, and our answer would be 53 marbles. All right, so just to remind us how to substitute and apply order of operations in a problem, let's find the value of 2x minus 3 when x equals 5. So remember, when we have a problem like this, we need to write the problem first. Then we're going to substitute in the value that we're given for x, and that's 5. So we write 2 times 5 minus 3. Now, according to the order of operations, we need to look for parentheses and exponents first. We don't have either. So then we move on to looking for division or multiplication. We do have a multiplication problem here, 2 times 5. So we're going to do that first. 2 times 5 equals 10. Write the rest of our problem. And 10 minus 3 is 7. All right, another word problem. Bryce had $50. He gave Y dollars to his son. The remainder was then shared equally between his daughters. Express each daughter's share in terms of Y. All right, what do we know in this problem? This is a little bit more complicated. Well, we know that Bryce starts off with $50. So let's draw a model for that. Here's his $50. We know that he has 2 daughters and that he gave Y dollars to his son. So let's draw some portion of $50, which is Y. And that's what Bryce gave to his son. We also know that he had 2 daughters. So let's divide up the rest of that bar model into two. We want to express each daughter's share in terms of y. So we're looking for an algebraic expression for each daughter right there. All right, well, we can see right away by looking at this model that if we want to express the amount of money given to both daughters, all we would have to do would be to say $50 minus y, right? That's easy enough to see because this is the amount given to both daughters, and all he did was take away y dollars and give it to his son. All right, well, Bryce has two daughters though, and our question that we're trying to figure out is how do we express each daughter's share in terms of y? Well, if this were a number, this would be easy, right? You would probably look at this, maybe you could say $50, he gave $20 to his son, not y dollars, and he had $30 remaining, and you would look at that and you would say, oh, that's easy. He gave $15 each to his daughter. And in your mind, you just divided that amount by 2. So remember, in algebra, we are using variables to express amounts that we don't yet know. So since we don't know this number, this amount that Bryce has left after giving money to his son, we're just going to write it just like we did up here, but now we're going to divide it by 2. And our expression for the amount of money that Bryce gave to each daughter is $50 minus y divided by 2. And that's it. All right, well, now we're being asked to substitute in a value for y. So it says if y equals $12, how much money did each daughter receive? So our first step, of course, is to write our formula from the last slide. So it was 50 minus y over 2. Now we are going to substitute in 12 for y. So we've substituted in 12. Now we have $50 minus 12 divided by 2. And now we're going to solve it. So 50 minus 12 is going to be 38. And then we're going to divide that number by 2. And we find out that each daughter was given $19. It was good to be a daughter in Bryce's family and not a son, because the son only got $12. So you might ask, this looks a little bit weird because I thought, according to PEMDAS, that we were supposed to solve division before solving subtraction. And the reason we did $50 minus $12 up here first is because it's this whole amount divided by 2, not just part of the amount. We could have actually also done it like this, where we divided both terms up here on top by 2. So that would have looked like $50 and $12 divided by 2, which would have been $25 and then minus $6. And of course, then we get the same answer. All right, so now we have Caitlin. Caitlin's allowance is $M each week. How much allowance will she have total after 4 weeks? This is easy enough to draw, right? We're just going to draw a bar model with 4 weeks in it. She gets $M each week. And if we want to write an algebraic expression for this, we're just going to write 4M. That's easy enough. Okay, well, during those 4 weeks, she also earned $12 from babysitting. How much did she earn in those 4 weeks altogether? So first we figured out that Caitlin had earned $4M in dollars in her 4 weeks of babysitting, but she also earned $12. So this is this part right here, and then she earned $12. How much did she get in those 4 weeks all together? Well, first she earned 4M, then she earned 12. So she earned 4M plus $12. How much money would she have made if her allowance was $12 a week? Well, let's start with our first step here, 4M plus 12. That was our formula that we just wrote a couple minutes ago. And now we're going to substitute in 12 for the m. And now we're going to solve it according to the rules of order of operations. So we have 4 times 12 is 48, plus 12. 48 plus 12 is 60. So Caitlin, are we talking about? Yeah, we're talking about Caitlin still. Caitlin earned $60 in those 4 weeks total. Now we want to know what Caitlin would have earned if her allowance was $5 a week. Go ahead and pause the video and see if you can set this up and substitute in 5 for m and solve it really quick. All right, go ahead and check your work. So remember that our algebraic expression looked like this, 4m plus 12. Now we're substituting in $5 for m, so $5 per week. And we're going to solve this according to order of operations. So multiplication first, 4 times 5 is 20, plus 12. And Caitlin would have earned $32. All right, now we're talking about Bella. So Bella is also a babysitter. And during 4 weeks, Bella made $100. B of it was from babysitting during that time, and the rest was from a weekly allowance. Write an expression for Bella's weekly allowance. So this word problem is a little bit more complicated because instead of getting information about Bella's weekly allowance, we're kind of working backwards from the total amount that she made. So Bella made a total of $100. Here's what we know. B of it was from babysitting during that time. So some portion of it, B, was from babysitting, and the rest was from a weekly allowance. So how many weeks are there in this word problem? Well, it says up here that there are 4 weeks, okay? So let's divide the rest of this amount into 4. And then it says, write an expression for Bella's weekly allowance. Well, let's take this in stages. Before we write an expression for Bella's weekly allowance, let's just go ahead and let's check this amount out right here. And let's write an expression for the amount that she made from allowance and not babysitting. So if we look at this, she's got $100 total after 4 weeks. B of it was from babysitting. So we can say that $100 minus B is the amount that she had from a weekly allowance. I'm going to rewrite that over here. So she had $100 minus B. We also know that we're talking about 4 weeks here. So she made that amount of money from allowance over 4 weeks. So if we divide this by 4, that would give us the amount of money that Bella made from allowance in 1 week. All right, so the next question on your note says, what would her allowance be if she made $40 from babysitting? Go ahead and see if you can solve that right now and then come back and check your work. All right, so we decided that Bella made $100, B of it was from babysitting, and the rest of it was from a weekly allowance. So we had written 100 minus B over 4. So there's our expression. Now we're going to substitute in $40 for B, because that's the amount she made from babysitting, and divide the rest by 4. So 100 minus 40 is 60. Divide that by 4. And of course our answer, we divide 60 by 4, would be $15. So that is Bella's weekly allowance. All right, your next task is to finish problems J, K, and L on your own, and then come back and check your work. Go ahead and check your work. Pause the video if you need to, and Make sure you got them right.